Sir, unmute yourself.
Good afternoon, everyone. Today is lecture number 16 of this advanced concept in steel technology. And today we are discussing about this new topic uh, that is basically continuous casting. So I could have discussed this one with starting from the steel making processes, which is there in your syllabus. But since this part is there with your heat treatment part, so that's why I'm discussing this one right now, right here. So this continuous casting, so you people understand the casting simply means in layman word, that means we are giving a definite shape or definite size to a solidifying metal or solidifying alloy, right? So that means we you people understood that means we need a solid structure basically with a definite shape and size for a definite service, right? So without a definite shape and size of a solid metal or solid alloy, we cannot use in service. So that's why this casting process is required. Huh. And also we cannot use a liquid metal, basically we use solid metals and solid alloys. So you can see here liquid steel casting give desired shape and size to solidify metal. Then solid steel with definite shape is generated, which is used in service. So for the steel, the old technology is called ingot casting. That is a batch process. That is not a continuous process. Batch process means one by one you have to cast it. Hmm. Here what happens basically, metal poured into a mold and definite shape is generated. So we have liquid steel, then we'll pour into a mold with a desired size and shape which we want. Basically, we'll pour it, and after solidification, we'll get it finally. But what is the new technology? New technology is called continuous casting, right? So here what happens? We're continuously pouring the liquid steel and continuously withdrawing the solidified metal or here the steel from the mold from the bottom part. Hmm. To generate this one, an endless slab bloom billets, right? So these are the main products of continuous casting. One is slab, bloom, and billet. Hmm. They have different shapes. They have rectangular shape, square. They can be cylindrical shape, kind of thing, right? And you have to remember this, after this continuous casting, these products are called semi finished solid products, huh? They're not complete finished product. These are semi finished products. But to get finished product, we have to do mechanical working on it, huh? Or metal working on it. And recently continuous casting products are direct thin slab or thin strips we can get. So here you can see the difference between the traditional casting, which is ingot casting. This is the figure showing you ingot casting, where we have many molds. This is one mold, this is another mold, this is another mold, this is another mold. We have various molds, right? And this is the liquid metal we are pouring into the mold, and upon solidification we'll get an ingot, right? But continuous casting, you can see from the top we are pouring the liquid steel, and from the discharge end, that is the bottom end, we are withdrawing our steel in form of a endless ingot kind of thing, huh? Endless ingot, or this is endless piece of solid steel. Hmm. Now this is a figure which will show you the difference between slab, bloom, and billet. You can see this is the shape and size of the slab. Size is not fixed here actually, but this is a slab. The shape and the bloom shape is like this, and billet shape is like this. So many people get confused here. So next you can see, yes, already I have discussed this one. Continuous cast products are basically rectangular, or it may be which is rolled into plate and sheet. So this is the thing. If this is a rectangular product obtained from continuous casting, you can plastically deform it by mechanical working to get plates or sheet or coil also. You can write coils. If it is basically square, then we can roll it into some round rebars, angles, channels. T's, beams like this. Hmm. That means from this one. If it is circular, basically we can get some this kind of ice, it's a beam, this rods and other products. Now you can see continuous casting machines are identified by the shape of the product they cast. Hmm. That means you are going to cast the rectangular products, or going to cast circular, or going to cast square kind of thing. Or these are the things. According to continuous casting machines, can be billet casting machine, it can be bloom casting machine, it can be near net shape casting, beam blanks, dog bone casting machines, around casting machines, a slab casting machines, a thin slab casting machines, or casting machines. So different casting continuous casting machines we can have, depending upon the shape basically. Now this is an interesting figure. You can see image showing finished products from semi-finished products. You understand the semi-finished products are obtained from continuous casting process, and finished product will obtain after doing mechanical working on it, by doing rolling kind of thing. We'll get the finished products, basically. So you can see if we have a slab which is obtained from continuous casting, then it can be converted into plate, or can be converted into sheets, or it can be converted into coils further. These plate sheets can be converted into coils. So these are the finished products. Hmm. Then if we have a bloom, then it can be given a structural shape like this. The finally you can get a rail kind of thing. Then similarly, if we have billets, we can get bars out of it, we can get rods also finally from it. So these are the finished products basically. These are semi-finished. Now the question is, what is the cause of evolution of continuous casting? So as I told, in traditional casting, that is called ingot casting. But ingot casting have lot of demerits, disadvantages are there. So which leads to development of this continuous casting process finally. So these are the causes. One of the causes is to increase the yield. By doing continuous casting, we can increase the yield actually. The loss of metal during casting will be higher in case of ingot casting, but here the loss of metal is minimum, or it is negligible, you can say. So there is an increase in yield. So loss of metal loss will be less. So here it is minimizing the loss of metal during casting. And the rate of production also increases. So you understand it is a continuous process. Continuous casting is a continuous process because we are continuously pouring the liquid steel from the top and withdrawing the liquid steel from the bottom continuously to generate an endless product. To generate endless product, you can imagine, continuously pouring, continuously withdrawing, and the rate of production is very high. Because in case of ingot casting, you have to pour the liquid metal into one mold first. After that, again you have to pour into another mold, like this. So this is a batch process, so the rate of production is low. Then another interesting point is minimizing the casting defects. So both continuous casting and ingot casting have defects, but the defect in case of continuous casting is very low. It is minimum defects we have. Hmm. So in other words, I can say, to improve the quality of the cast products, we are going for continuous casting. Basically, the product quality is better here in case of continuous casting. Basically, whenever we are talking about segregations, segregations of alloying element or segregation of impurities are more in case of ingot casting. Basically, they used to get segregate along the center of the cast product. But here, in case of continuous casting, the segregation is there, but it is minimum segregation will be happening. And we'll see after sometimes, maybe, like we are using this agitation processes during continuous casting also, the different reasons, so as to get minimum segregation, by using those uh, magnetic stirring technology. Then increase the cost efficiency. So we can increase the cost efficiency also, because continuous casting cost is minimum. Yeah. Now, what are the advantages of continuous casting or ingot casting, which already we have discussed here already? Then there's certain other advantages we can have. You can see this is one of the limitation we can have is the capital cost for the continuous casting is very high. That means you understand. That means when we have to install the machine, the entire machine of the continuous cast, in short, it is called concast basically. The capital cost is very high. But if you look into the operating cost for the long term, it is low. So this is the advantage we can have. And second very good advantage we can have by using continuous casting of steel is it produces near net shape that are close to the final products shape, due to which we require less deformation. So this is important. See, if we are obtaining a cast product which shape is completely closer to the final product, so that is an advantage. That means we do not have to deform it more. We do not have to consume lot of energy during deformation, because you understand while rolling or forging a particular component, a lot of energy is consumed. So if that means a lot of deformation is required. But in case of continuous casting, nowadays we can obtain near net shape. That is very important. Near net shape obtained means deformation required after that will be minimum. The cost required will be minimum. It will minimize the cost. Then this is another important point. Can solidify large volume of metal into simple shape. So a large volume of metal can be solidified by giving a simple shape. We can deal with large volume of metal. So this is another important advantage of this continuous casting process. Now, sequence of elements required for continuous casting. So here elements means one single component I am talking about. So what are the different components involved during continuous casting of steel? So you can see we can have in the top. So this is the sequence also. In the top we have a molten steel present in a ladle. So ladle is the first element. So ladle will carry molten metal or molten steel from the furnace. And this molten ladle is nothing but it is just a reservoir kind of thing, which brings molten metal or molten steel from the furnace. But it is a bottom opening ladle. That means the bottom part can be opened, so that the liquid steel can be timed into the tundish. So tundish is the next component we can have. So tundish is basically a reservoir. It's basically a reservoir which store a lot of liquid metal or liquid steel here. And another point is uh, this tundish can be connected to different molds. Suppose we at a time we want four cast products, so we can have four molds. So these four molds can be filled by a single tundish, right? So tundish is nothing but a reservoir of molten steel. It can fill continuously four or five or six or eight or nine, like this number of molds. And tundish also protect the metal or the steel from reoxidation, because from the top of the tundish we have a synthetic slag present. This synthetic slag will cut off the contact of this liquid steel with the atmosphere, right? So there will be no reoxidation of steel will happen, because if the steel will reoxidize, that is a loss. Less yield will be there. Loss of metal will be there. And also here the synthetic slag which is present on the tundish also absorb the non-metallic inclusions. So if non-metallic inclusions will get absorbed, then it is very good, because we can produce a clean steel also. So that means another advantage of continuous casting is we can produce clean steels. We can produce clean steel which are free from non-metallic inclusions, right? Because you remember, if non-metallic inclusions are there, that creates some problem during mechanical working, right? That is basically leads to the crack formations, because they are very hard and brittle. The next to the tundish we have a SEN, submerged entry nozzle. So this is a refractory materials which is dipped into the mold. So this part is the mold part. This is actually copper mold, the mold made up of copper, because copper have high thermal conductivity. We can easily lose the heat from the liquid steel, so that a solid skin will form. Solid skin of steel will form. Then this mold is basically water cooled copper mold, and this mold is a oscillating mold. It goes up and it goes down. So this oscillation is very essential, because the steel will not stick to this mold. It can be easily withdrawn from the bottom. And we are also using some kind of lubricants, mold powders, which forms a layer in between the liquid steel and, or you can say solidified steel, or incoming liquid steel with the mold wall. So the steel should not stick to the mold wall, basically. Then we have these rollers, withdrawal roller. They withdraw the steel which is just solidified from the mold. Then we have some, it is not there, but I will show you. We have some bending unit and supporting rollers. Bending roller and supporting roller, because finally we want the steel which is going vertically will become horizontal. So we have supporting rollers and bending rollers, which bend the steel and support the steel further, right? Because why? Because you understand, the surface of the steel is solidified, but inside part is still liquid, or in the mushy zone, it is semi-solid kind of thing, and it has a ferrostatic pressure. Due to ferrostatic pressure acting on the solidified skin, may break the skin, or it may generate some cracks also, right? Then further we have, you can see now, this is a straight part, and after that, and as I told, this is an endless product we are getting, but we need a particular length. So we have a torch, which is gas kind of torch, which cut this length which is desired for us. So it will be cut and it will be sent to the your mechanical working section, where there will be rolling, basically, or forging unit. Okay, let me show you this one again. So you can see what is the advantage of this continuous casting. Again, we can have clean steels. Clean steels means steels free from impurities, as well as free from this non-metallic inclusions, basically. Like these non-metallic inclusions, you understand. The example is like, this steel will be free from this silicates, aluminosilicates, basically silicates or aluminosilicates, any oxides, uh, any sulfides, basically. So this is one of the advantages. The second advantage you can see here is reduce segregations. As I told, segregation we cannot completely eliminate it, but we can minimize the segregations. Segregations means, you understand, inhomogeneity, or some alloying elements or impurities will get segregated at the center part of the cast product. Then the next, we can avoid reoxidation. Already I have told you how we can prevent reoxidations. Reoxidation can be prevented by using synthetic slag, as I told, in the tundish part, because the synthetic slag will float on the tundish. Top of the tundish will be having the synthetic slag, which cut off the contact of this liquid steel with the atmosphere, right? So the oxygen cannot be, there is the oxygen access will be not there into the steel, so we can prevent reoxidation. And then we can see we are using this submerged entry nozzle. Submerged entry nozzle is connecting tundish in one end and disconnecting mold in another end. So this is a refractory tube, so metal will flow from the tundish via this submerged entry nozzle into the mold. So there is no air, direct contact with the air here, right, or to the atmosphere, or to the ambient atmosphere. So it prevents reoxidation. So that is another part. So it is already there: ladle, tundish, submerged entry nozzle here. Then we have a oscillating water cooled copper mold, which I have told you, it moves up and down. The downward speed is somewhat high, upward speed is less, basically. And then we have this, you can see this part is the steel, but here we have rollers, and we have cooling units. You can see this blue part is the cooling unit. We are spraying water and air both to make it solidified completely. And then we have bending zones, supporting rollers and bending rollers. As I told, they will bend the vertical part into horizontal part. And finally, we have a cutting torch, gas cutting torch, which will cut the specimen into a desired length. Then it will move to the next unit, that is rolling or forging unit, basically rolling unit, mechanical working unit. You can see this is a ladle, and this is steaming the liquid. Steaming the liquid means it is supplying the liquid from the bottom to the mold. This one is the oh, sorry, this is a tundish. This one is the tundish, which is shown over here. So this is the tundish, this one, and this is your ladle, and this is the metal going into the tundish. And these are some cut part of the cast products. Hmm. So this is the last content we have. You can see this is a very good image. This is a mold, water cooled copper mold. You can see. So I have shown you the half part. So this is the middle part, you can imagine.
Sir, unmute yourself.
Oh, sorry, yes. So you can see here we have this is a half cross section of the mold, and I have shown you the liquid still inside the mold. What is happening inside the mold? You can see. So you understand the mold part, and the part of the mold will be here in this side, and this is the submerged entry nozzle, SCN. So you can see, and this is your flux or the mold powders or flux powder, which is covering the steel from the top so that it will not get oxidized, and it has other functions. It creates a lubrication effect in between the mold and the steel. This here only is form a layer here in between the wall of the mold and the liquid steel present in it. And you can see also this red part. This is a solid part or the solid skin of the liquid steel, and this is the liquid steel. This is the steel is still in liquid condition, but this has been solidified due to contact with the mold, because it is a water cooled mold, as I told. So solidification happens from the mold wall first, right? And you can see the flow of the liquid. The liquid is flowing from the tun dish to the SCN, and it is going like this in this direction. The speed is very high actually, but I'll in the next class I'll tell you how the speed of this liquid still is controlled here. This is flow direction. Then you can see here, this arrow marks is showing the ferrostatic pressure. So liquid steel will have a pressure which is applying a pressure on the solidified skin of this liquid steel, so that there is somewhat bending will occur. Hmm. It is not shown here exactly, but there is some bending will be happening. Right? So you understand here, that means inside the mold, complete solidification is not happening. Only the skin part is getting solidified, or the outer layer of the steel is getting solidified, which is for this inside part will further solidified by spraying water and air, as I told. In these conditions, you are spraying water and air. And another important point is written, this cooling is happening by help of thermal radiations, due to radiations effect, due to convection effect, due to uh, roll contact cooling, because these are the rollers. Due to contact of this steel with the roller, some cooling is happening. So this is called roll contact cooling. Okay, fine. So I will end the topic here. We'll continue the lecture from the next class.